Assalamualaikum and hi everyone, especially to Sir Isha. Hey guys, I'm Elia Fahana with Kamal and people call me Elia. Come in. And my name is Ishnu, I'm Rabin Tijani and people call me Umar.
And my name is Damia Kasina Shua and people call me Wawa.
And she is the leader. We are from ECM157 1B2.
So right now we are going to proceed our first experiment, which is permeability test using our soil. And also we have a container and we already made 9 holes under it. So let's go. So first we place it here and we pour the soil into the container. So now after we pour the soil into the container, we are going to compact it. So right now we are going to put this cup under our container. So right now we are going to pour our water into our container. That's it. So right now we are going to use our second sample, which is a sand. We are going to use the same test that Elia did at the first try. So let's go. So right now we are going to do permeability test, which is we already find our soil.
Pour the soil into soil sieve set to remove the coarse aggregate. Close the lid and shake it to produce heat.
And we are going to measure it using our measure scale. And here is we are going to pour it into the container. And
Okay, so right now we are going to compact this soil.
So we are going to measure the height of the soil after we compact it.
okay, so right now we are going to use our second sample, which is a sand. So right now we are going to measure the weight. So let's compact our sand. Cepat. 3.5 cm.
Weigh the actual weight of the brick first before placing it in the oven. And then take the brick out to weigh the weight of the brick. So this is the result for the first brick and this is for the second brick.
So right now we are going to measure the brick weight after we soak it all night. Yeah. So now for the second brick.
Today we are going to do our second test for brick, which is a paper test for mechanical test.
Let's go.
So right now we are going the second sandpaper, which is fine. Now we are going to weigh the result.
The first is for result of medium sandpaper, while the second one for fine sandpaper.
Assalamualaikum and a very good morning. So today I will talk about description and type of material that we are testing. So I'm going to talk about our first material, which is soil. Soil is a natural material that forms on top layer of the earth's surface. It is composed of mixture of mineral, organic matters, air, and water. Its properties such as texture, composition, and strength is really important in construction. Different types of soil like clay and sand behave differently under pressure and water content. And as for the origin of soil, it is formed over a long period through the weathering of rock and the accumulation of organic matter. Physical weathering was caused by temperature change, water, and mechanical force, causing it to break a big rock into smaller particles. And other than that, it can also caused by biological activities. When plant and animal decompose in the soil, they break down into smaller substances or particles. When it mixes with soil, it will make the soil even richer and stronger. So right now, let's talk about our second material, which is brick. So brick is one of the oldest materials and it is widely used in the construction. And brick is building material that is made from natural clay, mixed with water and then molded into a rectangular shape, then fired into a kiln at a very high temperature. So the reason why brick has been used for a very long time is because they are easy to get, produce, long-lasting and suitable for many types of construction work. So it can be used for any type of construction work. For example, like building wall, pavement and other structure. Back in the day, the brick are formed using wet clay and then it was dried under the sun, and later on a simple kiln will develop so that we can fire the brick.
In construction, understanding soil properties is very important because soil with low permeability are very useful in construction. They are used for dams, embankments, landfill liners because they help to stop seepage. The soil also acts as natural water barrier, preventing water from passing through. However, soil can also cause problems. Some soils have poor drainage, which can lead to waterlogging. They may also experience swelling and shrinkage, which can affect the stability of the structure. Another issue is foundation settlement, where the ground sinks or moves over time. In addition, some soils are difficult to compact uniformly, making construction more challenging. So how about high CBR soils? For example, gravel and well-compacted sand. They provide strong load-bearing capacity, making them ideal for runways, roads, and heavy foundation because they are already strong and they just need some require thinner pavement layers which help to reduce construction costs. Stabilized soils. When wet soils are mixed with stabilizing materials such as cement, lime, or even brick dust, their CBR values are going to improve, making them usable for the constructions. This method also allows to sustainable use of additive and waste material, reducing environmental impact. How about low CBR soils such as soft clay and organic soil? Low CBR soils are weak under load, making them unsuitable for pavement or heavy structure. To be used safely, they require stabilizations or thicker pavement layers, which is increase the construction costs. Variable soil performance. Natural soils are heterogeneous, meaning the CBR values can be differ in different parts of the same site. This requires extensive testing and sometimes ground improvement technique to ensure the soils can support construction properly. Well-fired clay bricks are highly durable because this brick is low permeability. They resist water absorption, which help prevent dampness in the wall. This also reduces problems like electrophorescence and slow down the long-term deteriorations, making the structure last longer. Brick with high permeability absorb water easily. This can lead to cracks, weakening of mortar, and even rising damp in walls because they take in too much moisture, the structure becomes less stable and require more maintenance. Clay bricks with the strong surface hardness produce less dusting and maintain their appearance for a longer time. This can help extend the aesthetic life of facades. They can also withstand mechanical wear and handling during constructions, making them more durable and reliable on site. Excessive surface wear. When bricks have excessive surface wear, they tend to produce dust and create uneven finishes. This not only affect to the appearance but also lead to higher maintenance costs over time.
So we are going to talk about sustainable practice or innovation. So of course we are going to start with soil. And some of the way that we can do with soil is by soil stabilization, which is mixing the soil with lime, cement and fly ash. This will make it much stronger. And other than that, we can reuse the soil from the construction site. It can be for backfilling, leveling or landscaping. And last but not least, we can add organic matters or plant. By putting the plantings, it can help strengthen the soil and prevent erosion. And as for the SDG 11 impact, it can reduce waste and protect natural resource. And it also provides stronger and much safer foundation for us to build road and building. And lastly, we can use local soil to reduce the cost for transportation. And it also can less air pollution, low cost and much cleaner environment. And as for the brick, we can use eco-friendly brick types. Some of it like fly ash brick, compressed earth brick and recycled plastic brick. So the benefit of using this brick is that it uses wasted material or natural soil instead of traditional clay. And other than that, it can reduce energy use and lower carbon emission. And last but not least, it has a good strength and insulation. It's durable building and fewer repair needed. And as for the SDG impact, it protects natural land and reduces pollution from brick production. Other than that, it supports safe, long-lasting and energy-effective building. Last, it leads to cleaner air and much more affordable construction.